Okay, we are learning how to solve quadratics by square roots. Solving quadratics by square roots. Quadratics by square roots. Okay, you can draw on your paper, do cute little things. You know, make your paper super cute. But all right, so say for example you have 3x squared minus 5 equals 31, right? We're solving, meaning what value of x would make this statement true. You could also graph this and see where this parabola, this function, crosses the x-axis right here, right? That's what solving means. What is the x value when y is 0? This is your x-axis, this is y. When y is down here at 0, what is your x values, right? So we're looking to see what is x equal. So this means 3 times what number squared, if you subtract 5, will give you 31. Well, you could do it in your head and try numbers, but most likely, you know, it might be a decimal. It might not be a whole number. So how do you do that? Well, you would add 5 to get rid of the 5 because you want to isolate your x value, add 5 over here, and then bring the 3x squared down, and that will give you 36. So we added 5 to get rid of this minus 5. You're left with 3x squared. You add 5 over there, so that's 36. And then that means 3 times x squared. So undo the multiplying by dividing by 3 on both sides, and that gives you x squared equals 12. 36 divided by 3 is 12. Now we want to get x by itself. There's a square there, so the opposite or the inverse operation of squaring is, you got it, square rooting. So you're taking the square root of 12. Don't leave it like that. Make sure you list all your perfect squares either in your head or on your paper. You should know these by heart. 3, 4, 5, 6. Just keep going, right? Make sure you know these. 7, 8, 9, and keep going all the way to 20, okay? The square root of 1 is 1 because 1 times 1 is 1. The square root of 4 is 2. It's actually plus or minus 1 because also negatives are involved, because a negative 2 times a negative 2 would also give you a 4. So there's 2 options, right? So make sure you go down the list. So is 12 on here? Is there a square root of 12? No, there's not. So we're going to break it down. We're going to break it down. The square root of 12 is the same thing as saying the square root of 4 times the square root of 3. So pull out perfect squares. So the square root of 4 is plus or minus 2. And then you keep this one just how you see it, because it's not a perfect square. So take out the perfect square and then keep the non-perfect square. So x equals plus or minus 2 radical 3, a positive or a negative 2 radical 3. Some kids also do it this way. This is called looking for perfect squares. So write that down. This is for if we're looking for the highest perfect square you could find. Some people just do a factor tree. They start listing random numbers, 6 times 2, 3 times 2. Just keep going till you can't go anymore. And then they circle their doubles and bring that double out as one number, and then keep the non-double inside. It's the same thing, however you want to do it, but looking for doubles or looking for your highest perfect square and simplifying that, okay? So x equals positive or a negative 2 radical 3. Let's try another one. That's example 1. Make sure you label that in your notes. Example 2, negative 4x squared plus 3 equals negative 21. All right, the whole goal is to get the x on its own. You want to isolate x on this side of the equal sign. Well, there's a 3 here, there's a square, there's a negative. They're all in the wrong place. So let's subtract that 3, subtract this 3 as well. Okay, so that cancels out. Bring down the negative 4x squared, the whole thing, right? Negative 21 minus 3 is negative 24. This says negative 4 times x squared. So undo that multiplication by dividing by negative 4. Divide this by negative 4. So 24 divided by 4 is 8. No, 6. 6. Okay, and then we want to undo the square. So square root. So x equals the square root of 6. Can you break that down? Not really. You can do a factor tree. 6, you can do 3 times 2. And that's it. Don't use 1. Only use numbers that are not 1. It cannot be broken down. There are no doubles, so you cannot break it down. So keep it just how you see it. Your answer is x equals plus or minus radical 6. You can't break that down. All right. We'll do 2 more examples. If you don't understand doing the factor tree, watch my video on that. There's lots of videos on that online. You can go on TikTok, YouTube, my YouTube. Look for radicals or square roots. Like, it's, yeah. That's a more primary concept, so we're not going to go deep into that in this video. Okay. Next one. 1/4 x squared equals 12. All right. The whole goal is to get this x squared by itself, right? We want to isolate the x variable there. So some kids do divide by 1/4. That's cool. You can do that. That way you're not confused. So x squared equals 12 divide by 1/4. Here's the thing. We don't divide by fractions. So make a side note here. We'll note in your box here that 12 divided by 1/4 is not the same thing as 12 divided by 4. So don't even try it. That's why it could be confusing. How do you take 12 and divide it by 1/4? It makes no sense, okay? 12 divided by 1/4 is the same thing as saying 12 times 4. So you times it by the reciprocal. You take the 12 and times it by the 4. You don't divide by fractions. Okay, so you can do this. That's cute and everything, but rewrite it and say, or better yet, 12 times 4. Make it make sense. All right. Okay, that's 48. Another way you could do it as well. So that's kind of like intro math, kind of like one version, I guess. Mathematicians don't do that. They just times the whole thing by the reciprocal, 4 over 1, or just 4. It's the same thing. So the opposite, or the reciprocal, 1/4 is 4 over 1, or just 4. Just times everything by 4. Get rid of this fraction. And then 4 times 12 is 48. So that's the more proper way of doing that. Just put the 4 outside and put parentheses and show that you're multiplying everything by 4. Okay? That's proper. Okay? This is like the visual way of doing it, so you can visually see it, but you're just timesing it by 4. Okay? Cool. Now, let's take this 48. We're going to take the square root of both sides. You might sometimes see me do it this way. If you see me do this, same thing. You're just taking the square root of both sides. Okay. All right, so x equals the square root of 48. So there's two ways of going about doing this. Find the biggest perfect square will be the easiest. Remember, we have 1, 4, 9, 16, 25, right? Find the biggest number to multiply to give you 48. This one's the biggest one. So take your biggest perfect square. You can break down 48. We're rewriting it where we have a perfect square and another number, the highest perfect square. So 48 is the same thing as saying 16 times 3. That is a perfect square, the highest one that you can find in this list. The square root of 16 is a positive or a negative 4, right? Perfect square. Non-perfect square is radical 3. And there you go. If you don't like that way, then do the tree thing, which is easier for many people. Because you might not be able to quickly reach for 16 times 3 that quick, like in your head, but you can quickly do 12 times 4 or 6 times 8, right? So, okay, let's do 12 times 4. And then just keep going until you can't go anymore. 4 times 3, 2 times 2, 2 times 2. Just give me all the factors until you can't go anymore. Again, 1 is off limits. Circle your doubles. Your doubles come out as one number. Give me another double. That comes out as one number. You're multiplying. Non-double is the 3. So all these hanging numbers at the end is what you look at. 2 times 2 is 4, radical 3. Which one looks easier? This way or the tree? That's your preference. Most people say this way because it's quicker. There's no tree involved. But if you can't quickly reach for 16, then just start factoring random numbers. You could do it the other way. You might have reached for a 6 and an 8. Same thing. What times what gives you 6? 2 times 3, 4 times 2, 2 times 2. Just keep going until you can't go anymore. There's a double. It comes out. There's another double. Pairs. Find your pairs. And then a non-pair. Same thing. Sometimes you have bigger numbers and it's hard to find the highest perfect square. It's going to be one of these though, usually. So if you can't reach for it, say you're looking for radical 108, just start going. 2 goes in a 10, 5, 2 goes in a 8, 4. So 2 times 54 is 108. Start with 2. Start with a low number. If you don't know what times what gives you 108, just always start with like a 2 or a 3. And then keep going. What times what gives you 54? 9 times 6. 3 times 3. 3 times 2. So to be honest, by the time you sit there and think, which of these numbers, if I multiply it, would give me 108, just do your tree. That's what I do. I'm a math person, but I don't have these memorized. Like I don't know which one of these numbers, if I multiply, would give me 108 that quick. So it might be 9 and 12, maybe. So I just start doing my tree. Circle my doubles. There's a double. It comes out as one number. And then there's a double here. Pairs. Non-double. Has no pair. Stays inside. 3 times 2 is 6. So that's why the tree is nice when like it's a big number and you can't think. What's your highest perfect square? You can do the perfect square way. You have to just play around with it. Try maybe, I guess it's 36, obviously. So it's 36 times something. 3. But see, like, who would know that, right? Like, that's not an easy one. 36 times 3, is that 108? 6 times 3 is 18, carry my 1. It is. But who would have gotten that quick, right? So the square root of 108 can be broken down be 36 times 3. That's your highest perfect square of this list. The square root of 36 is 6. And then keep your non-perfect square. See how that one's easier because it's just one row of numbers. This is like all these rows, this whole tree. So it doesn't matter, but this way might be faster because you can just quickly go. Circle your doubles right here and then keep your non-double inside. Again, if you don't know how to do factor trees, watch my other video. Okay, last example. Right. Say you have -3 x plus 2 squared equals -36. So we're solving for x. -3 times what number add 2 if you square it would give you a -36. Okay, so we want to untrap this x. We want to free it from the jailhouse. So we need to first get rid of this security guard right here who's guarding the door. So divide by -3. -3 parentheses means -3 times. It's a multiplication. So to undo multiplication, you divide by that same number. Divide over here. Keep that squared. It doesn't go away yet. 36 divided by 3, 12. Now that you got the guard out the way, get this little birdie up here out the way. Remove the bird so you can untrap, free the x out of the jail. So how do you undo square? Square rooting. So now you've freed. Took away the bars, jail bars. All right, so let's go to do this. 12. That one's easy. Use your numbers, right? What times what gives us 12? 4 times 3. Perfect square. Bring it out. Non-perfect, keep it in. Make sure you subtract this 2. Because x needs to be by itself, so subtract the 2. 2 minus 2, get rid of it, and then subtract it over here. So your problem will be x equals -2 plus or minus 2 radical 3. What if it looked like this? It's the same thing. Divide by this +3, right? That was negative. This one's positive. Divide by that same number. Divide here, right? Do the same thing. So this x minus 2 equals radical 12. Radical 12 is 2 radical 3, right? Same thing. But this says -2 or -2. That one said plus. So what if it was a -2? Then you would add 2, get rid of it. So add 2 on the other side. Add 2 to get rid of it. So on this side of the equal sign, you're adding a 2 to the situation. Not subtracting a 2, but just adding. You could put add 2, but you don't need to put add 2. You don't have to say x equals +2. X equals 2, same thing, right? Okay, so that's how you do those, and that is solving quadratics using the square root method. I'll do one more for you. 5 times x minus 3 squared equals 375. What's our first step? Divide by 5. We have removed the security guard. 375 divided by 5. Well, let's do some math here. That's 7, 35, 25, 75, right? And then square everything, right? Square root everything. So, do your tree. It'll be easier if we can reach for a perfect square. 75, 75, ooh, right there. Is the same thing as saying 25 times 3, right? 3/4. We got it. That's the best one we can find. Perfect square. 5. Non-perfect. Stays in the house. This 3, subtract 3, we add 3 to this other side of the equal sign, right? To get rid of it. So x equals 3 plus or minus 5 radical 3. This 3 should not be over here, right? Minus 3. No, 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 no. Add it to get rid of it, right? You're adding it on the other side as well, the equal sign. You don't need to say I have positive $3 in my account. No one says that. No, you say I have $3 in my bank account, right? You don't need to put the plus 3 at the end, but I'm showing you that you're adding the 3 on the other side. Okay? So x equals 3 plus or minus 5 radical 3. That's your answer. That's what the x value is. If you were to graph all of these equations, you would find that the x-intercept is at around 2 something. 2 plus around 2, around 4. It'll be around 4 over here, negative 4. Somewhere around there, you would see that. 3 plus about 5, that's about what, 8? It'll be at positive 8 and negative 8. Something like that, right? Or not, well, no, that's not true. 2 plus 2 is around 4, right? 2 minus 2, around 0. It'll be around 0 and 4 if you would graph it. 3 plus 5 is 8. 3 minus 5 is negative 2. If you were to graph this, you would see it was around negative 2 and 8. 3 plus about 5-ish, right? It's about 8. 3 minus about 5 is negative 2. So it'll be a decimal point, but it'll be around those two x-intercepts there if you were to graph it. So that's solving by hand if you notice a square root method. If there's a squared involved and it's nice and easy looking like these problems, then just use the square root method. Make it nice and easy. All right, bye.